This is Euclid Book 10, proposition number 92, and it says, if an area be contained by a rational straight line and a second apotome, the side of the area is the first apotome of a medial straight line. Okay. For let the area AB be contained by the rational straight line AC. Okay. So the area of AB is this right here. It's ADBC. This area right here. Okay. And it's going to be contained by a rational straight line called AC, which is right across here. And the second apotome, which is AD. This is a second apotome across here. Okay. I say that the side of the area AB is a first apotome of a medial straight line. Okay, so that's what this line is going to end up being when we get done. For let DG be the annex to AD. Okay, this is DG and it's going to be the annex to AD. Therefore, AG and GD, GD, are rational straight lines commensurable in square only. Okay? So the only time that AG and GD are commensurable is when they are squared. Okay? And that's what these two represent right here. Now, what does that mean? Okay? It means that we took the line AG and we turned it into a square. And all four sides of that square are going to be the length of AG. We also took the line GD, which is across here. We turned it into a square. And all four sides of that square are going to be the length of GD. That's what that means. That's by Euclid Book 10, proposition number 73. And the annex DG, which is right across here, is commensurable with the rational straight line AC set out. Now, this is a rational straight line. Okay? And this is commensurable to this. Okay? While the square on the whole AG, okay, that's this square right across here, is greater than the square on the annex DG, so this is actually going to be bigger than this. How much bigger is this than this? Well, it says, by the square on a straight line commensurable in length with AG. This is by Euclid Book 10, third set of definitions, number 2. Since then, the square on AG, that's this one, is greater than the square on GD, that's this one right here, by the square on a straight line commensurable with AG, therefore, if there be applied to AG, we're going to apply something to this, okay, a parallelogram equal to the fourth part of the square on GD and deficient by a square figure, it divides it into commensurable parts. This is by Euclid Book 10, proposition number 17. Let then DG, this is going to be DG, it's going to be bisected at E. Okay? And let there be applied to AG a parallelogram equal to the square on EG and deficient by a square figure. Okay? Now, what is the square on EG? Well, we take this EG right here and we turn it into a square. And all four sides of that square are going to be the length of EG. That's represented by this. Okay. Now, the parallelogram that's been applied to AG, okay, the parallelogram that's been applied to AG, which happens to be equal to the square on EG, actually ends up being the rectangle called AFFG. Two sides are AF, two sides are FG. So this rectangle has the same amount of area as this square. Okay. Therefore, AF, which is this length right across here, is commensurable with FG, which is this length across here. Okay? But AG is rational and incommensurable in length with AC. AG is a rational straight line and it's incommensurable with AC. Okay. So far, so good. Now let me get a drink here real quick and we'll continue on. Okay. Let's go on here, shall we? Therefore, each of the straight lines AF and FG, well, here's line AF right here, and here's line FG right here. Both of those lines are rational and incommensurable with AC. So, this line right here is rational and incommensurable with this. This line is also rational and it's incommensurable with this. And that's by Euclid Book 10, proposition number 13. Therefore, each of the rectangles AI and FK are medial. Okay, what is rectangle AI? ACIF. All three areas here combined, okay, if you add all these three areas combined, it's going to be medial. Okay, now what's the area FK? Well, it's FIKG. That's this one area right here. It is also a medial area. Again, since DE is commensurable with EG, since DE is commensurable, okay, with EG, since this line is commensurable with that, therefore DG is also commensurable with each of the straight lines DE and EG. Okay, so what does that mean? Straight line DG is commensurable with DE. DG is also commensurable with EG. That's by Euclid Book 10, proposition number 15. But DG, we've already proven, is commensurable with AC. Therefore, each of the rectangles, DH, what is DH? Well, that's DBHE. That's this rectangle right here. This rectangle is rational. What about EK? What is EK? It's this area plus this area combined. Okay? All of that area is rational. And that's by Euclid Book 10, proposition number 19. Let the square LM be constructed equal to AI. Okay. This is square LM. Okay, it's this plus this plus this plus this. It's all of this area right across here. All of that area is going to be equal to this area plus this area plus this area. All three of these equals this. Okay. And let there be subtracted NO. Well, what is NO? That's this little square right here. That's NO. And it's going to be equal to FK. Okay? So this little area here is going to be equal to this little area right here. And being about the same angle LM. Well, what's LM? Well, it's LPM. That's your angle right there. It's a right angle, but that's what it is. And so the angle, of course, is LPM. Therefore, the squares on LM and NO are about the same diameter. Okay, what's square LM? Well, it's all this area in here. What's square NO? It's just this little tiny area right here. Okay? And this is by Euclid Book 6, proposition number 26. Let PR be their diameter. Okay, PR is the diameter of this square. Yes, you can have diameters of squares as well as circles. And let the figure be drawn, which it has been drawn. Since then, AI and FK, well, AI is this plus this plus this. FK is this area right here. They are medial and equal to the squares on LP and PN. Okay, what is the squares on LP? Well, we're going to represent them here. Okay. What's the square of LP? Well, what we're going to do is we're going to take the length of LP and we're going to turn it into a square. And all four sides of this square are going to be the length of LP. Okay. Now, what about square PN? Where do we get that from? Well, here's PN right here. And we're going to take this length, we're going to turn it into a square, and all four sides of that square are going to be the length of PN. That's where that comes from. So now what they're saying is, alright, what they're saying is that the area of AI, which is this plus this plus this, if you add this area to all three of these, you'll get the same amount of area as this plus this. The squares on LP and PN are also medial. These are medial squares. Therefore, LP and PN are also medial straight lines commensurable in square only. So, the line LP is right here, the line PN is right here. The only time that this giant line and this small line are commensurable is when they are squared. Okay. And since the rectangle AFFG is equal to the square on EG, so this area equals this area. Therefore, as AF is to EG, okay, as AF is to EG, that's this giant length is to this giant length, so is EG to FG. So is this length to this length. That is by Euclid Book 6, proposition number 17. While as AF is to EG, as this is to this, okay, as this whole line is to this line, so is AI to EK. So is this plus this plus this is to this plus this. And as EG is to FG, as this whole thing is to this, so is EK to FK. So is this plus this is to this alone. That's by Euclid Book 6, proposition number 1. Therefore, EK, what is EK? That's this plus this together. EK is the mean proportional between AI, which AI is this plus this plus this, and FK, which is this little tiny thing right here. Now let's review. This plus this together is the mean proportional between this and this and this, and this alone. This is by Euclid Book 5, proposition number 11. But MN is also the mean proportion between the squares of LM and MO. Okay, so what is MN? Okay, MN is this area plus this area combined. That's these two areas. It is the mean proportion between LM, which is the whole area in here, and NO, which is this little area right here. And AI is equal to LM. This plus this plus this is equal to this whole area right across here. And FK is equal to this little area right here. Therefore, MN is also equal to EK. This area right here is equal to this area right here. Okay? This plus this is equal to this plus this. But DH, where is DH? Okay? DBHE, that's this area right here, is equal to EK. So this area is equal to this plus this. And LO is equal to MN. Okay? What is LO? It's this plus this. What is MN? It's this plus this. Therefore, the whole DK, this plus this plus this, is equal to the nomen UVW and NO. What is the nomen UVW? That's this plus this plus this, and then you add this little extra square on top of it. Since then, the whole AK, so this plus this plus this plus this, is equal to LM and NO. So if you add all four of these together, you'll get this area plus this little tiny square. And in these, DK, which is this plus this plus this, is equal to the nomen this plus this plus this, and add this on top of it. Therefore, the remainder AB is equal to TS. This area right here, which is ACBD, okay, is equal to TS. What is TS? That's this area right in here. Okay? But TS is the square on LN. Okay. TS is actually the same amount of area as if you were to take line LN and you were to make a square out of it. Okay? So I want you to take LN and I want you to make a square out of it, and all four sides of that square are going to be equal to the length of LN. And when you do, that area up there will be equal to this area right here. Okay, all this right here. Therefore, the square on ln, that would be this one up here that we just drew, is equal to the area of AB, which is this area right here. Therefore, ln is the side of the area AB. This is this. I say that ln, this right here, is a first apotome of a medial straight line. For since EK, well, that's this plus this, is rational and equal to LO, so these two areas combined are equal to these two areas combined. Therefore, LO, which is this plus this, that is the rectangle LPPN. Okay, so now we're going to make a rectangle right across here. Two sides of that rectangle are going to be the length of LP. The other two sides are going to be the length of PN. Okay? Therefore, LO, which is the rectangle LPPN, this area is equal to this. It is a rational area. But NO was proved medial. This little tiny square was proved medial. Therefore, LO is incommensurable with NO. This area is incommensurable with that. But as LO is to NO, as this whole area is to that, so is LP to PN. This length to this length. This is by Euclid Book 6, proposition number 1. Therefore, LP and PN are incommensurable in length. This is incommensurable with that. Therefore, LPPN are medial straight lines commensurable in square only, which contains a rational rectangle. Therefore, LN, this line right here, is the first apotome of a medial straight line, which is by Euclid Book 10, proposition number 74. And it is the side of the area AB. Therefore, the side of the area AB is the first apotome of a medial straight line. And that is the whole proof. All right. I will tell you more in a future video, so I want you to stay tuned. Okay? I want you to stay tuned.